Hey guys, I'm going to continue working on this. I got like 15 minutes free, so let's see how much I can get done. All right, simplified to a single expression. Cotangent is 1 over tangent, which I could rewrite as cosine over sine. And then secant is 1 over cosine. So cosines cancel out, 1 over sine. So that's going to be cosecant. Next one, let's distribute this. Sine x over, this is going to be cosecant, which is 1 over sine. So sine x minus sine squared x. Sine x minus sine x is 1. 1 minus sine x squared x. We can use the Pythagorean identity to know that this should be cosine squared x. Number 3, 1 minus sine squared x. We just used the Pythagorean identity there. I probably did that on purpose, so you don't have to think too much about it. But either way, 1 over sine squared x is cosine squared x. Cosecant minus 1 is going to be the Pythagorean identity that leads to cotangent squared x. So it's going to be cosine squared x over 1 divided by cotangent squared x, which means we want to reciprocate it, so times it by tangent squared x, which is sine squared over cosine squared. So cosine squared times cosine squared, 1 on top, 1 on bottom, which means this leads to sine squared x. This one, we need a common denominator in order to add this. So this one needs a cosine squared on top and bottom, or just a cosine. And this one needs a 1 plus sine on top and bottom. So this is going to become cosine squared x plus 1 times 1 is 1. 1 times sine, sine times 1, that's going to be 2 sine x. And then we have sine squared all over 1 plus sine x times cosine x. All right, with that in mind, this cosine squared and sine squared could be combined together to become 1. So this will add up to just a 1. And then let me condense some terms. So I'm going to have 2 plus 2 sine x over 1 plus sine x times cosine x. Cosine x. Well, if I cross these out, I can factor out 2 here and then cross it out. So I have a 2 and a 1. So it's going to be 2 over cosine x. Remember, this is going to be a multiple choice. So this is not how your answer is going to look like. Your answer is going to be 2 secant x. Okay. Verify the identity. So we need to prove that these are equal to each other. In this one, it'll be a multiple choice where you have to check basically the proof of somebody's to see if it was all true. So I'll do one proof, but there's multiple ways to do it. In the left and the right, you need a 1 plus cosine, or this one needs a 1 minus cosine, apologize, 1 minus cosine. And this one needs a 1 plus cosine. So this is going to be sine theta. I'm just going to skip writing the variables. So sine x plus cos sine. Oh, these are multiplication. Oh, I made a big mistake. Okay, so this is multiplication, so I don't even have to do all that. With that in mind, since it's multiplication, I could just multiply straight through. So this is going to be sine minus sine cos. And then on the bottom over here, it's going to be 1 plus cosine times 1 minus cosine. That's the difference of squares, or cubes, or squares. So that's going to be 1 minus cosine squared. Well, 1 minus cosine squared on the bottom becomes sine squared. And then if I didn't distribute the sign or factor out the sign now, so sine 1 minus cos, I don't know why I put a dotted line here, but 1 minus cos, sines cross out, this has only 1 left over, which becomes 1 minus cos over sine, and there's our answer. But this is a multiple choice question, so you got to just check if all the answers make sense. If there's something they did, like a legal move or something wrong, you got to not circle that one. All right, cosine squared minus sine squared equals 2x cosine squared. I need to make this sine into a cosine. So what I'm going to do is change sine squared into 1 minus cosine squared with the Pythagorean identity. Distribute the negative 1 and rewrite it. So it's going to be positive cosine when you distribute it. So 2 cosine squared minus 1 equals what we have here. So we're good here. This one, I'm going to change secant to 1 over cos minus cos over 1. Need these to be a common denominator. So I need this to be cos. I need a cos over here. So it's going to be 1 minus cos squared over cos, which 1 over cos squared I can rewrite as sine squared over cos, which means I could rewrite this something like this. Sine over 1 times sine over cos, which means this could become tangent. So your final answer is sine tan. This one, I always like to round or move down. Again, you don't really have a choice. You just got to look at the multiple choice and see if they make any errors effectively or not. Secant minus cosine over secant is sine squared. So let's rewrite this. 1 over cos minus cos over 1 over 1 over cos. Now I want you to point out we did secant minus cos here. I don't think anyone realized that during the test, but you already did this work. So I'm going to skip right to the end here and get to 1 minus cos squared over 1 over cos. Okay, 1 over cos squared is sine squared over 1 over cos. I'll just rewrite it as a secant, I guess. What can I do from here? I get stuck. Did I make a mistake? Wait, secant minus cos is definitely 1 over cos, cos over 1, cos, so it's 1 minus cos. Oh, my fault. I didn't even read my old work correctly. On the top, it would become 1 minus cos squared over cos divided by 1 over cos. Because both of these coses are on the bottom, I could cancel them out. So it's just 1 minus cos squared, which is sine squared. For this one, solve the following equations from 0 to 2 pi, plus 1 on both sides. Tan x equals 1. So then, from here, you have to do inverse tan. So tan equals, x equals tan negative 1 of 1. So you need to figure out where or actually that's not true. Let me rephrase that. You ask yourself where or what tan values causes this to be 1. So what causes this to be 1? If you know your unit circle, pi over 4 and 5 pi over 4. Now, can we use a calculator to help us with that? Yeah. So, in this one, you could do tan negative 1 of 1. Put the mode, if it's in degrees, it might help you easier to see it, but it's 45 degrees. aka pi over 4. So that kind of matches what we said. Let's just check if we can, because tan 5 second pi over 4. In this case, because I'm putting in a radians, put the options in radians, and I press enter. That's a 1. Looks like it works. So those are your answers. This one, we need to solve the equation, so we want to get x by itself. So I'm going to plus cos on both sides. So this will be cosine, 2 cosine, my bad, not cosine squared, plus 1 equals 0. Let's factor out, not factor out, let's subtract 1 and divide it by 2. Cosine x equals negative 1 over 2. So I'm looking for what cosine values causes x to be negative 1 over 2. And remember, since it's multiple choice, you can just take the answers and plug them into cos x if you really want to. But either way, the answer here, since it's a half, that means it's the shorter side. So that's going to be the 60-degree ones, or the pi over 3 ones. And then since it's negative cosine, it has to be in the second quadrant, so 2 pi over 3. And the third quadrant, which is going to be 4 pi over 3. And again, you could plug in 2 pi over 3 into your calculator of cosine x, and you can see that's the answer. Here, we're going to do plus 1 on both sides, then divided by 4 equals sine squared x. Square root both sides. So it's going to be sine x equals plus or minus 1/2. Now you have to ask yourself, what causes sine to be both plus or minus? Don't forget that. 1/2. So what can I plug in? So this is the short side. So it has to be the pi over 6 family, or the 30 degrees. So pi over 6. And since it's positive negative, I want all 4 values. 5 pi over 6, 7 pi over 6, and 11 pi over 6. This one, I need to factor out cosine. Cosine x times cosine x minus 1 equals 0. From here, I could split and solve each one separately. So cosine x equals 0. So all the places where cosine causes to be 0, since it's the x value, that must be straight up and straight down. So pi over 2 and 3 pi over 2. And then cosine x minus 1. So we want where cosine x equals positive 1. So where all cosines equals 1. And cosine equals 1 would only be at 0. It's not at 2 pi, because if we look at the original equation, it says the domain being 0 to 2 pi, not including 2 pi, but it's a soft parenthesis. So it's just these 3 answers. Remember, pi is a negative 1, so it wouldn't work there. For this one, we're going to take sine g is 3/5 and cosine h is 12/13. Find sine g plus h. So the sine one is, you know what? Rather play it safe. Trig identities cheat sheet. Because I don't want to make a mistake, and then you guys tell me later I made a mistake, and then I have to make a new video. Where's the sum? What the? Oh, this has some. There we go. It's sine cos, yeah. All right. So this is going to be sine g times cos h. Wait. Sine cos, yeah. Cos h plus sine h cos g. Okay, so then sine g, we already know is 3/5. Cosine h, we need to do the triangle. Adjacent, so is 12, this is 13. Do a little bit of Pythagorean theorem, this is 5. And then let's just do this one quickly because we're going to need it. This one is 3 on the right. Oh wait, opposite is 3, hypotenuse 5, this should be a 4. So cosine here is going to be, oh wait, we already know what cosine is, so it's just 12 over 13. Plus sine of h, which is going to be opposite over hypotenuse, so 5 over 13. And cosine of g is equal to this one adjacent to hypotenuse, so 4 over 5. So this is 36 over 63 plus 20 over 63. So your final answer here is 56 over 63. How can you check that? You put sine 56 plus over 63 into here, and see if that's the same as sine 3 plus, or you plug in. So if you wanted to figure this one out, you could do, just do it the long way, I don't know. You'll plug it in your calculator if you want to. All right, cosine g minus h. So cosine is inverted. So cos first? Yeah. Cos g cos h plus sine g sine h. But you could kind of abuse the fact we already found cos g and cos h. Cos g and cos h, which is 4 over 5 and 12 over 5. 12 over 13, my bad. Plus sine g, which we already found was 3 over 5 in the previous one, sine h, 3 over 13. So this is 36, 38, my bad. No, 48. 48 over 63 plus 9 over 63 equals 57 over 63. Yeah, I guess they should be close. That makes sense. All right, tan 2g. So we use the double angle for tan 2g, which is where? That double angle formula is right here. So tan 2 theta is 2 tan minus 1 tan squared. So tan, in this case g, I guess. Yeah, tan g minus, or over 1 minus tan squared g. Okay, tan g. So we could look at our triangle from the beginning. Tan is opposite over adjacent. So it's 3 over 4. So 3 over 4 over 1 minus 3 over 4 squared, which is 9 over 16. 3 over 4 divided by 1 minus 9 over 16 is 7 over 16. We flip that. 3 over 4 times 16 over 7. Reduce the 4s to 1 and 4. And that's it. So it's 12 over 7. Sine h divided by 2. So we would do a half product, half angle formula. So sine plus or minus the square root of 1 minus cosine over 2. So plus or minus the square root of 1 minus cosine of h. This should be of h. So cosine of h, which we did in the past, is 12 over 13. So 1 minus 12 over 13 over 2 is in the square root. So that's going to be the square root of 1 over 13 divided by 2. You say over 1. So that's going to be 1 over the square root of 26, which we would like to rationalize. Root 26 over 26. All right, evaluate 22.5. To be fair, I'm going to show you how to do it, but you could use the calculator to confirm with all the answers, like if the decimal matches what sine 22.5 is. But this is a half angle, So we know it's going to be sine 45 divided by 2. So I can rewrite this as plus or minus the square root of 1 minus cosine of 45 over 2. So cosine 45 is root 2 over 2. So you have square root of 1 minus root 2 all divided by 2, all that divided by 2. So maybe I should write it like this. 2 divided by 2 divided by 2. Which is just the same thing as multiplying by 1/2. So then you can rewrite this as the square root of 1 minus root 2 over 4. Well, you can square root this piece on the bottom. So square root 1 minus root 2 over 4 over 2. Did I make you do any more about this? Where's this? Guess that's it, yeah. Yeah, that's it. Did I do any more about this? The square root of 2. The 2 on the bottom is not in the square root anymore. 1 minus square root 2. Square root, square root. I guess that's it, yeah. All right, system equations. Solve however you like. Now, however you like, you could do elimination here, which is you're going to add here. So negative 3x equals add 24. X equals negative 8. Take that negative 8, plug it back into here. One of them, I'll plug it into the bottom. So 4 times negative 8 minus 4y equals 0. Negative 32 minus 4y equals 0. A little bit of algebra. Y equals positive 8. So negative 8, positive 8. Oh wait, no, negative 8. So negative 8 comma negative 8. Okay. Now, how do you use your calculator to your advantage? We're going to use something you haven't done since Algebra 2, or I guess Algebra 1 for you guys, which are matrices. Now, how can we use matrices? Well, second matrix, oh wait, wrong thing. So we're going to go to, not y equals, my fault. We're going to go to matrix here. Now, we want to go to second matrix, but we don't want the we don't want the names. We want to go to edit. So go right twice to edit. We're going to click enter. And what we're going to put in is the 4 numbers here. So negative 7, 4, 4, negative 1. So it's a 2 by 2. And it's negative 7, 4, 4, negative 4. All right. Second quit. Let's go to matrix again. Let's edit the number B. So this is, you're going to put the answers here. So it's 24 and 0. So 24. Oh, wait, I'm sorry. I have to make it a 2 by 1. So 2 by 1. Not by 11. 2 by 1. There you go. And then from there, we're going to put 24 and 0. Now you're like, okay, what did I do all that for? Well, if you click second matrix, A, to the negative power times second matrix B, what you get is negative 8, negative 8, which means you could use your calculator to do system equations. Let's try it with the next one. Before you do that, though, you have to make sure it's written in kind of like elimination format, all on the same side. So on this one, I'm going to rewrite as negative 7x plus 2y equals negative 10. And then 14x minus 4y equals negative 20. From here, you could do elimination or whatever you want to do. You know what? I'm just going to do elimination, and then I'll show you in the calculator. So this is going to be, I'm going to times the top by 2. So negative 14x plus 4y equals negative 20. 14x minus 4y equals negative 20. So subtract down, or add down. So that's going to be 0, and 0 equals negative 40. Because 0 does not equal negative 40, this is a no solution. These are parallel lines. This one, the cubic ones, you cannot use the calculator on the matrices. But for here, and I'm not going to do the previous one because I already showed you how to do it on the matrix. You can just review the video if you want to, or Google how to do system equations on your calculator. Here, we could do substitution. So negative 2x plus 2 equals negative x squared plus 2x plus 7. Then I'm going to solve set equal to 0. I'm going to move it so that x is positive. So it's going to be x squared minus 4x minus 5 equals 0. So it's going to be x minus 5, x plus 1 equals 0. So your x are negative 1 and positive 5. These are your x values. Now I have to both individually put the x values up here to do each one. So for this one, negative 2 times 5 plus 2. Negative 10 plus 2 is negative 8. So one answer is 5 comma negative 8. And the other one is negative 2 times negative 1 plus 2, which is 2 plus 2 is 4. So the other one's negative 1 comma 4. But you're like, Mr. Tobel, you just said the matrices only works for normal ones, no quadratic ones. So what can I do? Well, we could use graphing to our advantage. So I'm going to click y equals, and I'm going to graph both of these. So y equals negative x squared. Make sure when you click negative, it's the negative button on the bottom, not the negative, like a subtraction button, or you're going to get an error. Plus 2x plus 7. And then down here is going to be negative 2x plus 2. And I'm going to graph that. And I'm going to click zoom standard, zoom 6, just to make sure it's clear. Okay? Now, you're like, well, what the heck does that tell me? It doesn't tell me anything, Mr. Tobel. Well, what I could do is second trace. That's going to be calculated. And then we're going to go to option 5 is intercept. Now, it's going to ask me for both curves. So I'm going to ask for first curve and second curve. I just press enter and enter. Now, there's only 2 curves on your graph, so it should be easy. The guess is going to be basically not guess like you're guessing. Guess as in, please tell me where I'm guessing. So they want you to tell them, hey, I want this one on the top left versus this one on the bottom right. So I'm going to press enter again, and I get negative 1 comma 4, which was one of my answers. I'm going to do the same thing, calculate trace, intercept, which is number 5, enter, enter. When on the guess this time, though, I don't want the negative 1 comma 4. I already know it. So I'm going to go down here, put my guess cursor over here. Press enter, 5 comma negative 8. So that's how you could use the calculator to graph the answer. For this one, again, let's rewrite it so y's are by themselves. So y equals 2x squared minus 5x plus 6. And over here, y equals minus 4x, so 3x minus 2. All right, set them equal to each other. 3x minus 2 equals 2x squared minus 5x plus 6. Divide, subtract these over here, so negative 3x minus 3x plus 2 plus 2. So 0 equals 2x squared minus 8x plus 8. Let's divide everything by 2 here. So 0 equals x squared minus 4x plus 4. So your answers are x minus 2, x minus 2 squared, which means you only have one real answer, which is 2. Okay, take the 2, plug it in one of the equations. I'll plug it into the bottom one. Y equals 3 times 2 minus 2. 6 minus 2 is 4. Y equals 4. So it's 2 comma 4 is your final answer. Let's just check how we could do that in the calculator. Now when you put it in your calculator, you got to make sure it's in y equals mode. So let's do it again. Y equals 2x squared minus 5x plus 4. 2x squared minus 5x plus 4 plus 6 plus 6. And then over here, 3x minus 2. All right, let's graph it, see if it's on the camera. This one is tough, right? It looks like it. So if you ever need to, you could click zoom in. So option 2 in this case. And then move your cursor kind of close to the thing. So you move your cursor a bit closer, click enter, and it might zoom in a little bit better for you. Either way, you're going to take second trace. We're going to look for intersect, so option 5. First curve, second curve, let me guess. It should be around here. If you have a trailing numbers like that, it's because there's estimation, but it's going to be about 2 and about 4, so you can use that to confirm your answers. All right, this one. X squared, y squared equals 25. 2y equals x plus 5. Problem with this one, you cannot do the graphing because it's a circle and the calculator can handle circles. At least I don't know how to make the calculator handle circles really well. So I'm going to solve for x. So 2x plus 5 equals x. And I'm going to take this x and plug it in over here. So that's going to be 2y plus 5 squared plus y squared equals 25. So here we're going to take that. 2y plus 5 squared is the same as 4y squared plus 1020y plus 25. Plus y squared equals 25. Combine the y squares, 5y squared plus 20y. Subtract 25 on both sides equals 0. Take out a 5y. And then is left over is y plus 4 equals 0. So your answers is 0 and negative 4. That's your x's. So then we take that, plug it into one of the equations. Probably the bottom one is easier. And I could do the rewritten bottom one if I wanted to. So it's going to be 2y plus 5 equals 0. Oh, these are the y's. My fault. So these are the y's. My bad. So then I'm going to plug it in the y's. I don't know why I said plug it into x's. So 2 times 0 plus 5 equals x. So that's 5 equals x. So it's your one answer is 0, 5, which I think people guessed and checked for that one. And then this one, and then negative 3, 4, it was also guessed and checked. 2, 3, 2, negative 4, my bad, plus 5 equals x. So that's negative 8 plus 3, negative 3. So negative 3, 4. Negative 3, negative 4. All right, I'm going to stop right there. I have to take care of something. So hopefully in the next video I can finish.